So if you're watching this, you were probably struggling a bit with these questions. So let's see how you did. Okay, so first of all, solid barium hydroxide is added to water. Will it dissolve? Write the formula with the proper state. So first of all, from writing our compounds, our ionic compounds before, I know that barium hydroxide is going to be BaOH2. So now I'm going to be using my table of solubility. And you're going to take the last half of the equation. So I'm going to look at my OH, the anion, and I'm going to find it in my table of solubility. So I'm only looking at the chemicals in this column. Even if you see Ba in other places, ignore them there because we're looking for Ba attached to OH. So here we go. So group 1, I'm going to have a quick look just to make sure. And you can see that Ba is not in group 1. It's in group 2. Okay, so it's not going to fall under that category there. It's not NH4. So that means that because the Ba doesn't fall in this row here, that means it's not aqueous. Again, anything that falls in that first row is going to be aqueous. Anything that falls in the second row, we're going to say is solid. So that means since Ba is not in group 1, it's not NH4, it's going to fall into that most. So I'm going to give this a state of solid. Now, if you actually worked with this in the lab, you would see that some of the barium hydroxide would actually dissolve in the solution, but you would still have a lot of the crystals in the bottom of the solution. So a lot of it doesn't dissolve. That's what that slightly soluble refers to, is that only some of it will dissolve. So we give it a state of solid. Okay, so let's try the next one. Ammonium, oops, I'll fix that so that you won't see that 4 there. It should be written like so on yours. There we go. Okay, so ammonium sulfide. So I'm going to look up the second half of the equation, find it, that's your anion, and you find that at the top. Okay, here it is. And now I'm going to look and try to find my ammonium. Okay, there it is. So since it falls in this first row here, that means ammonium sulfide is going to end up being aqueous. Okay, let's try another one. My next one is silver chloride. Okay, so I've got for B, silver chloride. Again, you're going to look up the anion or the second substance in the formula. You find it at the top of the chart. There's my chlorine. I'm trying to find the silver Ag that's attached to it. So it's probably going to be aqueous, but I'm double check. Oh, and there it is. Okay, so it's actually going to be solid. Next, this is actually lead 2 sulfate. Again, we'd have to go back to, if you're, it's just because I've done so much chemistry, so I'm familiar with a lot of the chemicals from using them over and over again. I know that lead has a charge of Pb2 plus or 4 plus. Okay, so it could be either one of those. Sulfate, though, if you look at sulfate under your polyatomic ion chart, you'll see it has a charge of 2 negative. So notice how these aren't written with subscripts. Yes, there's that 4 there, but that's because it belongs to sulfate. That SO4 is sulfate. So I know is that because there isn't subscripts there, that it had to be that Pb2. And it does matter for this one here. Well, I'm not sure if it matters for this one. Let's see. Okay, so now I'm going to look up sulfate. There we go. And I'm going to look for my lead 2. And here's where I'm saying that it matters. Because if you had chosen that lead 4, that would fall under most, and you would have told me that it's aqueous. But by looking at the actual charges to figure out which lead I have, I can tell it's the 2 plus, 2 negative, those cancel out. Okay, and then there is that lead 2, so I'm going to give this a solid state. Strontium hydroxide. Again, look up that OH at the top of the table. Looking in this column, I'm looking for strontium. Okay, strontium is a group 2 element, not a group 1. Here it is. So I know it doesn't fall into the most category. Sorry, which one was I on? Strontium. So it doesn't fall into the group 1 category. It's not ammonium, so it's going to fall into most. So again, since it falls into this last row, I'm going to say that it's a solid. Okay, next, same one again. Iron can actually have a charge. If you look in your periodic table, it can have a charge of 2 plus or 3 plus. Hydroxide, on the other hand, only has a charge of 1 negative. So seeing that I had to have 3 OHs to cancel out the charge, I know that this is the ion that I used, right? Because 3 negative, 3 positive, that would give me a charge of 0. Okay, so let's look that up again. Iron 3 oxide. In this case, you would have lucked out because both 2 and 3 fall in that most. So if you weren't able to tell them, you should have still been able to know that it was solid. Gold nitrate. I'll give you guys a little clue here. In high school, anything that we pair with nitrate is always going to be aqueous. You can always double check. I never do, just because I know, do a lot of chemistry. Okay, so I'm going to look anyways. I can tell that this one here, because gold can be gold 1 or gold 3. Nitrate just has a negative charge. Okay, so now I'm going to find my nitrate. There it is. Okay, and all substances are soluble in nitrate except for, well, nothing, because these are the chlorates, this one here. So that's my aqueous state. Okay, so you can save yourself time if you remember that. If not, you can always just consult your table. Next one here, again, I can have lead 4 or lead 2. Iodide, however, can only have a charge of 1 negative. Okay, so to get a total charge of 0, 1 negative, can't be this one because I'd still end up having, this would have been PbI2. So I can tell it's that one. Okay, so now I'm going to check my iodide. There we go. And I'm looking for lead 4. So it's probably going to be aqueous. I'll double check. Oh, there's that lead 2. So this would be a great question to put on a test to make sure that students understand 2 concepts, which ion it is and how to use their solubility chart. Okay, so it is not that lead 2, so it's going to fall under the most, which means it's aqueous. Next one, sodium phosphate. Okay, so sodium is a just regular substance that doesn't have more than 1 charge. Okay, so I'm going to look up phosphate, PO4. There we go. I'm going to look for sodium. Sodium is a group 1 ion. Group 1, remember our groups are the vertical columns. There it is, group 1. So because it falls into group 1 and it's in that row, that makes it aqueous. Silver acetate. Okay, so I'm going to look up, this whole thing here is the polyatomic ion. Remember, when you're looking at a formula, if there's more than 2 capital letters in the formula, 1, 2, 3, 4, 5, 6, that tells me that something here is a polyatomic ion. Look at this one here, 1, 2, 3. That told me that something here is a polyatomic ion. This one only has 2. So nothing's a polyatomic ion. So this whole thing here is a polyatomic ion. So I'm going to find that up here. Here's my acetate. And I'm looking for silver. So it's probably going to be aqueous because of most, but if you check the second row, you can see it's actually a solid. Next, magnesium sulfide. So first of all, you're going to have to write the formula. Okay, and now I can look up the last part of the formula, the anion. There we go. And I'm looking for magnesium. Magnesium is a group 2 ion. There's my group 2. There's magnesium. So make sure you always check, because I find that especially when I'm making tests, I tend to choose ones from these columns to make sure that students, because again, I can be testing you on more than one concept. I can see, do you remember what a group is? Is that horizontal or vertical? And can you look them up and actually find them and then find the solubility? Okay, so I've got my sulfide. I've got magnesium, which is group 2, so that means it falls into this row, which tells me that it is aqueous. Last one, zinc nitrate, Zn, NO3. Okay, so I'm going to look up the last half of the question. Or did you remember our little trick about nitrate? Nitrate's always going to be aqueous, but let's just double check anyways. Here's nitrate. we can see it is aqueous for all substances unless it's attached to chlorate, which is not nitrate. So it's going to end up being aqueous. So there you go. So give those a try again if you've just watched this. If you're still struggling, remember you can always email your teacher to get some more help.